everyone. For this video, I am going to demonstrate to you how to perform the conceptual estimating. Estimating is a process of determining the projected cost of a construction project. As you've learned, there are several types of estimating methods depending on when are you going to prepare the estimate for that particular project, what particular point in time or the phase or stages to where you're going to prepare the estimate. As I've said, as you've learned in previous chapters, estimating it is a process of determining the projected cost of a project and comes in three different types or methods. The first one is the conceptual estimate. The conceptual estimate, it is a type of estimate wherein you have only a vague descriptions or a limited informations about the project, such as the square footage, the locations, and the time of constructions for the project. The second type of estimating is the preliminary estimate, which is commonly known as the square foot estimating. You get a little bit more information about the materials to be used or the other elements that comes into that particular project. And the last one is a detailed estimate, which you must have a complete set of drawings or specifications for you to be able to perform the detailed estimate. While the conceptual estimate that is usually established or developed at the beginning of the project, that is when you are starting to conceptualize, when you are trying to write the project programming or the conceptual of the project. The preliminary estimate, which is commonly used for budgeting purposes, to where you will be watching out the range of the cost of the project as you move on. And a detailed estimate, which is commonly used for bidding or to serve several other purposes, such as for budgeting and cash flow analysis. Alright, so for this video, I am going to show you how to perform the conceptual estimate, and that is the first method or the first type of estimating. Alright, so for this particular estimating, which is also called as the rough order magnitude or commonly known as the ROM. Now, for this particular type of estimate, you will be based on some very little informations or descriptions about the project, such as when you are building a hospital, you know how many bed capacity, or if there is a school, how many students capacity, or if there is a highway, that is in terms of a mileage or the length of the highway. Again, we'll be using based from your textbook. There are several table or indexes that are included in the textbook. However, I just want to caution you that those numbers are based on the 2009 index. It is based on a national average in which the RS means, which are actually the producers of that particular index, is to collect data or surveys from all over the United States and take the average of that one. So they call it the national average. Because it is a national average, they are subjected to some adjustment based on the locations and the time. Alright, so for this conceptual estimator, it has an accuracy of plus or minus 20%. That how much high it is because of the absence of very critical informations about the project. We don't know the materials, we don't know what would be the framing methods that we're going to use, or some of those other techniques that comes with the project. So again, when you will be using conceptual estimate, you need to explain that to your client, that variations of the accuracy of the project, which is plus or minus 20%. Alright, so when you use the conceptual estimate, there are several factors that you need to consider. First one is the project size. The next one is the quality of the project, and of course the locations and the time. Those are the factors that you need to put in into your calculations, and in the RS means table, it provides you some of those criterias or factors. All right, so how do we estimate the project? How do you project the estimated cost of the project using the conceptual estimator? Well, I provided you here a step on how you're going to calculate the conceptual cost of the project. So first, you need to determine the total cost of the project, depending again, whatever the given. If that is in terms of unit, you need to determine or to find the cost per unit. The same thing also, if it gives you in terms of the area, then you need to determine the cost in terms of the square footage. Alright, so once you determine the initial total cost, you need to adjust, as I mentioned a while ago, because this is a national average cost. It is it has to be adjusted based on key factors. The first one is the size, the project size. Because it is being taken in terms of an average cost, we are going to factor in whatever the current size of the project as compared to that average size. And that is being calculated. If the area or the square footage of the project is not given, you need to calculate that by determining the estimated unit size or the structure unit size of the project. That is just multiplying the units by the gross area, and I'm going to show you where you will be getting those factors for you to calculate that SUS. Once you determine the SUS, you need to determine what we call as the size factor. Okay? That is in relations to whatever that's typical that they use to figure out the average cost of a particular project. And then we will be determining the cost multipliers. The RS Means has developed a graph on how to calculate that cost multiplier that is based from the square footage. And then once you have the cost multipliers, then you have to calculate now the estimated cost based on this particular adjustment. The second adjustment that you're going to apply is the location. Because it's a national average, we are going to adjust that to wherever the specific locations of that particular project. And we will be determining the city index. And again, there is a table for us to be able to determine that city index. Once you calculate the estimated cost based on location, the next thing and the last thing that you have to do now is the time. Okay. Now, I just want to make it clear, the one that you have in the textbook is a 2009, and I'm going to stick with that particular table. However, we already have updated tables that we can find in the internet, or you could buy the RS Mint estimated books, which usually cost about $400. Probably they already have the 2020 estimating index. Alright, so to illustrate, I have here several numbers of illustrative problems. So here for this illustrative problem number one, if a building cost in Little Rock costs about $3,500,000 in January 2009, how much would be the duplicated building cost in Salem? So in this particular problem, we are going to compare a cost of a particular building that is located in Arkansas, that is a given cost in a given year, and we need to determine the estimated cost at a particular location at the same given year. Alright, so to do that, we are going to apply that principles that we have in the previous slide. This is the location comparison. This is the given, which is 3,500,000. This is the location index on that particular locations, which is Little Rock, and we're going to make use of figure 5.4, and I have reproduced here on your right the table. So this is in Arkansas, Little Rock, and you have here the weighted average that is 85.7, and that's the value that you're going to put it here at the bottom. Okay, and then we will be figuring out the cost in Salem and the location index in Salem, Oregon. So again, we have here Oregon, Salem, and we have here the weighted average, which is 100.2. So we have here 100.2 plugging in to this relationship, and then we need to just cross multiply this value here. And again, these values are in percentage. So you don't need to convert them in decimal as long as you deal here in terms of percentage, and this is also in percentage. If you want to convert that into a decimal, make sure that you convert both your denominator on the left and on the right. So cross multiply and divide that by 85.7, and that will give you 4,092,200. All right, so for the second problem here, we're asked to determine the estimated cost, that's the national average of building an identical building with its with cost 800,000 on July 1972. It's a little bit cut off here. Building built on a particular location, and it is 800,000. All right, so that's 800,000 in 1972. We're going to use the historical index, and that's figure 4.5. So again, you need to be consistent because we have here different columns. We are going to use the estimated column here on the current index. So we have here the current year, January 2009, that's 100. That's the national average. And in 1972, estimated current index, that is 18.7. So that's the reason why we have here 18.7. So for us to be able to determine the national average, you just need to cross multiply those two, and that will give you 4,278,100 if the same building will be built today, that is in 2009. Okay, that is building on January 2009. All right, so we have here another problem here. This time we need to convert a given unit into an equivalent square footage. All right, so for this particular problem here, it is a senior high school. It is built to be built for 1,200 students, and I want you to take note here, it's a high quality, because for this figure 5.2, it gives you here the 1/4, that's the low quality, that's the 25%, median, that is 50%, and of course we have here the 3/4, that is the upper 75%, that's the high quality. All right, so for a senior high school, for 1,200 students, what you do is just go and locate wherever this senior high school is. So in this particular case, we have here senior high school. Then I want you to go across high quality. So we have to go into the 3/4 column, and that gives you 145. That means that for every one student, it occupies about 145 square feet. And that's the reason why we have here this factor, 145 times 1,200 students, and that will give you the square footage. All right, so let's combine all those together into just one problem. All right, so here in this particular illustrative problem here, we have the first one. What is given here is a 70 unit motel. That's the type of the project. We've given here the number of units. There is a location, that is Anaheim, California, and it is constructed in 2007. All right, so for that, let us apply. So we have here July 2007 project, a motel. Location is in Anaheim, California. There are 70 rental units and a high quality, which is a 3/4. So first thing we have to calculate based from the steps that we have in the previous slides. We need to calculate first the initial estimated total cost, which is 70 units, multiplied by the cost per rental. So how do we figure that? We are going to use figure 5.1, page 76 of your textbook. It is reproduced here. It is a motel. It is per rental. We have here total project cost. It is in square footage or in cubic foot or in terms of the rental units. In this case, what is given here, and I want you to take note of that, it is given in rental units. It is not in the square foot. If it is in square foot, make sure that you're going to consider the total cost in terms of the square footage. All right, so we have three different columns here. This is the low quality, medium quality, and we have here the high quality. All right, so if it is a per rental unit, high quality is 73,500. That's the reason why we have here 73,500 multiplied by the rental unit, which is 70. Okay, and that will give you the initial cost of 5,145,000. All right, that is the national average. Because it is a national average, it is subjected to um, adjustment based on the size, the locations, and the time. And you will notice on the given here, we have the location and we have also the time. All right, so for us to be able to adjust the size, we need to convert this rental unit into an equivalent square footage. And we will be using figure 5.2 to figure out the equivalent square footage. So in this case here, this is your figure 5.2, and it is a motel, okay, rental units, okay, and this is the low quality, median, and we have here the high, and that is 620 per rental units. And that's the reason why we multiply 620 to 70 to give you 43,400 square feet. All right, with that, we should be able to calculate now the size factor, and that is just a typical building. That is from your figure 5.3. This one here on your right for motel, gross square footage for typical size, it's 40,000. That's the reason why we have here 40,000 here, and we have here your 43,000 that we have here. This should be 43,000 divided by, okay, this line here should be in between these two. Okay. All right, so we have here now the 43,000, that's the SUS, divided by the typical building. That gives you 1.085, or that is 1.1. I want you to round it up into the first decimal places. Okay, so once we have that 1.1, that's a size factor. By dividing your SUS by the typical, based from this table here, you can now determine the cost multipliers. And to calculate the cost multiplier, you will be using this graph here. Okay, and that's still on figure 5.3, page 78. What to do is just go across, it's 1.1. So from the horizontal at the bottom or at the top, that's your size factor here. Locate wherever this 1.1 here. So for this case, this is approximately the locations of the 1.1. Draw a vertical line into this graph until you intersect this curve here. Once you intersect that curve, draw a horizontal line, and you'll be able to determine what we call as the cost multiplier, either from the left or from the right. So with that, it will give you approximately about 0.97. So once you determine the cost multiplier, you will be able to adjust this initial cost now based from the cost multiplier, and that will give you 4,990,650. Then the next thing you have to do now is to adjust the location. The location for this one is in Anaheim. Now you will notice in this relationship here, this is 100 because that is a national average. Okay, if you will be comparing your cost from a national average to another location, this is always 1,000. If you will be comparing in between two different cities, and of course this value will change. Okay, that will be depending on wherever that particular location is. But since it is being compared in terms of the national average, this one is 100. Okay. All right, so the estimated total cost that we calculated in the previous is 4,190,000 divided by that 100. In Anaheim, we need to figure out the city index, which is in figure 5.4. This is your California. Okay, so that is 107 weighted average Anaheim, and we have here 107.0. Plug in here to this relationship, cross multiply, and this will give you 5 million. And again, I want to make sure that you get it, that this value that we are calculating is based on the year 2009, because the tables that we have on your textbook is based on the index in 2009. If you're going to make use of the 220 tables, then the basis will be in the year of 2020. Alright, so the next thing they have to figure out now is the adjustment based on time. So again, from the previous calculation of 5 million, plugging that to the adjusted cost at Anaheim, okay, for base year, because it's 2009, so that's 100 year. If you will be comparing that from year to year, then you might need to calculate that in terms of the index, historical index at any given year. But since we are comparing that in 2009, that is 100%. Okay, so calculate the estimated cost based on time, historical index, again page 4.5, figure 6.6. So we have here 2007, because that is what we are asked to calculate. See here, July 2007. So that will give you 91.1, okay, here. Now you might be asking, what about if that is beyond 2009? Well, from this same table that we're looking at here on your figure 4.5, if you're going to read the note at the bottom of that particular table, it tells you the projected percentage that you need to add per year. Okay, I believe the estimated projected increase per year is 5.1% from the historical. Okay, if you're going to read the note at the bottom of this particular table, it tells you that for you to be able to project beyond 2009 per year change, you need to add about 5.1%. Alright, so, and I think I have an example for that as we move on. Just cross multiply and divide by 100, and that will be gives you the final answer. Alright, so again, for this particular illustration here, it tells you what figure that you're going to use. You just need to follow this particular step. Alright, for the problem number 2, what we have here is a nursing home, Rochester. This time it's beyond 2009, so we have here 2013. Okay, and it is a low quality 1/4. Okay, note what is given here instead of the rental unit. It is in terms of the square footage. Alright, so first step is to determine the estimated cost, and that is 25,000. It's given, multiplied by the cost per square foot. Again, that is in page 84, 5.7, low quality, and the cost for that is 110. So again, we have three columns. One that corresponds to the low quality, that's a 1/4, median, that's 50%, and a 3/4, that is the high quality. So I want you to pay attention on those, okay? And you should get the right numbers in those columns. Alright, so that is the estimated cost, and that is about 2.86 million. And then you're going to do the adjustment. First one is the SUS. It's already given. You don't need to convert that. The next step is to determine the size factor, 26,000. Okay, that is given. Okay, 26,000. Well, I think this is 26,000. That's 25,000. So I make a mistake here. This should be 26,000. So that's why I use here 26,000 divided by 23,000. So again, that's typo. It should be 26,000 here. This is 26,000. Okay, just to make it clear. And then that will give you a size factor of 1.1. Look at again from the graph, and that is closest to that is 0.97. So this cost multiplier here, you multiply that to the initial cost, and that will give you 2,774,000. Alright, so next to the location adjustment. estimated total cost from the previous chapter, which is 2,774,000 divided by 100, because that's a national average. You have to figure out the city index based on the location, Rochester, New York. It has a 96.6 city index. Cross multiply and divide by 100. That gives you 2,679,000. And again, this is a 2009 cost. We need to adjust that based on time. Okay, for the time, we have here the estimated total cost, adjusted cost in Rochester, that is 2,679,000. That's from the previous. And you will notice here, because we have 2009 to 2013, 2009, that's 10, 2011, 2012, 2013, that correspond to 4 years difference. And as I mentioned a while ago, at the bottom of the historical index, for you to be able to project the increase per year, it is equivalent to about 5.1. That's the reason why here, from 2009, which is 100%, to 2013, that is 4-year gap. Multiply that by the increase per year, and that will gives you the historical index, okay, or the index in a given year. So cross multiply, so you have to multiply first 5.1 times 4 plus 100. Then multiply this one here, divide by 100, because that's a base year, and that will give you 3,226,571. So again, I gave you here step by step. It tells you what figure that you're going to use at every given step. Remember, as you use the conceptual estimator, you will be required to adjust that based on the size, based on the location and the time. And take note on the size. You need to factor in the quality of the project, whether there is a low quality, medium quality, or there is a high quality types of project. Alright, so for the square foot estimating, it is what we call as the preliminary. There are some elements or items or the methods or materials that are being involved in the projects are being identified already. So that's the reason why they call it the square foot estimating. The accuracy for this one, because we know a little bit more of the project, it goes down now to about plus or minus 15%. Unlike in the conceptual estimator, it is about plus or minus 20%. They have the same adjustment as in your ROM or in your conceptual estimate. They are being adjusted based on the size, the locations, and the time. Alright, so for this particular project here, we have a 15,000 square foot library. It is to be built in Little Rock, Arkansas, and we have here some assumption of face brick with concrete block and a steel frame. We are asked to use the model square foot cost. Alright, so again, we have here a median, 15,000, the type of projects library, and this allocation here. Alright, so this is the square foot table, and that is on page 85 of your textbook, and that is the figure 5.8. Alright, so the estimated cost, pretty much the same as the conceptual. We know the square footage of it, times the cost per square footage. However, in this table that we have here, there is no directly the cost for a 15,000. Because what is given here is 15,000. And on the table, we have only the range of 7,000, 10,000, 13,000, 16,000. We don't have any of those 15,000 here. To determine the cost for 15,000 square footage, we are going to make use of what they call as the ratio proportion or interpolation. Okay, we will be interpolating. So in this particular case, 15,000 is in between your 13,000 and 16,000 here, and that's the reason why we have here 13,000. The cost for that is 164.5, and we have here 16,000. We have 160.70, and of course the one that we need to find is the X. Alright, so what we could do is just subtract 15,000 minus 13,000. We have this. Then 16,000 minus 13,000. We have there at the denominator. And you need to be very consistent. What we have here at the top is we subtracted the second and the first. So that should be the same case as you move on to the right side. So we have here x minus 164, and that will give you this one here. So 160 minus 164, it gives you this one here. Arrange them, subtract these first, subtract those, and then cross multiply. Okay, this multiply this one here, and then divide by 300. Rearranging the equation, the cost is 161.97. As a checking, you should have a value that is between 160.7 and 164.5. And in our case here, we have 161.97. If you calculated a value that is less than 160 or above 164, you need to double check your calculation because that will be wrong. Alright, so we already calculated the cost per square footage. What we need to do now is just multiply the original size of the building multiplied by the cost per square foot, and that will give you the 2,429,000. If it gives you the time, the location, you should adjust the calculation as well to just as this one here. Okay, we did some adjustment okay for the cost. All right, so that's how you do the square foot estimating. All right.